Hi everyone. In this video, we'll talk about row ID tracking and how we can leverage row ID tracking to improve our merge queries. So for that, first I will introduce what is row ID tracking, and then I will show a simple table where we'll overwrite some data, then we'll convert it to merge queries, and we'll see how we can effectively do merges by leveraging the row ID tracking. So row ID tracking is a feature which is introduced in Spark or Delta, where it will create a row ID for each row. So let's create a simple table. So I'm creating a simple table. Now let's insert some rows. So since we have inserted, yeah, we'll insert some rows now. Once we have inserted the data, we can use this underscore metadata dot row ID. So this will basically give my number for each row, and it will be unique for each of the row. So let's see, right, that this is day one data, and we have data from the source today, right, and we need to basically update the data, right. So updating the data, a simple way, right, we can use a overwrite. So when you use override, it's like just you go there and then you completely wipe out the old data and then recreate the new data, right? So let's see. Okay, so this is a straightforward operation. It is, but the problem with this approach, as you can see, right, the row IDs are getting affected, meaning you will completely lose the lineage. Say, for example, let us go to the Excel. So in this Excel, see, this is my existing data, and this is my new data which we overwrite. But if you see it carefully, ID number one, there is no change. ID number two, it is a single row update, meaning it just has updated the value of the attributes, but there is no change in the start and end date. And ID number three is a multi row update, and ID number five is a new insert record. And we have another one row in the source, say 4, which needs to be deleted, right? But when we do this route, it looks like everything got deleted and reinserted. So what should we do now? So let's see how we can effectively do the merge. So if you see high level, right, for a beginner, if you see this data, one thing which is clear is whenever there is no change in the content, we should not rewrite the data. So let's first restore the data. So this restore command will basically restore my data as of version 1. So basically the data version which we had before the override. So let us confirm that. Yeah. So now we are back to the first step. So where we had 4 rows and it is having the row ID starting from 0. Now, so as per our initial understanding, so we are going to write a merge query. So in this merge query, we will basically write, what we need to do is we need to merge into the existing target table using the source data which we got, and what our initial understanding is, right, if the exact row is changed, we should not disturb it, right? So what we are checking is simple merge statement. So we are checking if IDs, description, and source date and start date and end date, right, if everything is same, then there is no change. So when everything is changed, we don't want to do anything. So when not matched, say if it is not matching, then we have to insert those rows. And if we have a row which is in source, right, and which is not present in the target, then we have to delete those rows, right. So since we have compared the values, in this case, since we joined by everything, all these rows except id number 1 will not be matched by source, right? So it will delete id 234 from source, and it will reinsert the new data for 2, 3 and 5, whereas for 1 there should not be any change. So let us execute this query. Meanwhile, I will copy the overwrite row ID. We can do a side by side comparison. So this is for row ID with overwrite. So it rewritten the complete data. Now let's see what happens with our first merge, like the unoptimized merge. So when I run this query, yeah, let us sort by row ID. Okay, now with the option one merge, if you see here, right, clearly the ID number one, right, where there is no change, we are able to effectively keep the source row, and we did not rewrite the data, right? But you can ask me what is the benefit, right? Like the benefit will be, say you have 100 million rows and only 100 rows are getting updated. You don't need to rewrite the entire data or all the files, right? You just need to rewrite the data only which has changed. So, but if you see here again, if you potentially see the source data, right, again I could see 2 and 3 rows, right? It is not a complete wipeout, but rather, right, something has only changed. But still in our merge option, right, it is not getting tracked properly, right? Because see, for 2 and 3 it's kind of a overwrite it has done, but the benefit is at least for no change rows it will not rewrite. Okay, now we this is good, output is good, right? You could see for id 3 2 rows are there and it is matching with 10 5, right? So this blue, right, whatever we have here, this blue will match these rows, and we have one where there is no change, so it is that green row. So we are able to match the green row, and for id2, it got from def to xyz. So we were also seeing that. So effectively the merge has, like, in terms of data, right, without, if you assume there is no row id field, in terms of the merge query, the query looks correct, or the output, in terms of output, it looks correct. But if you see keenly, right, it's like unnecessarily, right, it has rewritten id 2 and 3 for all the rows. Instead, what we might need to do is, for 2 it should be an in place update, it should just change the value rather than rewriting the complete row. So how should we do it? So that is when we can do an effective merge. So we have done the root cause analysis that the merge is happening, the data is correct, but it's not a perfect match, because you delete and insert certain rows where it's an update plus an insert, or just an update. So let's rewrite our query. So before rewriting our query, I will restore it to the previous version. Okay. Now check whether it is restored to the original set of IDs. Underscore metadata true ID comma star from sample data. Okay, but it's again still the same. So now if we go and see our actual data, right? So what we need is, effectively we have to check the ID column and the start date column. And if this is same, effectively we have to do an update. So for example, see both the the ID number 2, right? Like the start date is same, but the end date is basically sorry, the end date is also same, but the value is changing. And for us, for id number 3, again its start date is also different, right? So what we need to do is, basically we have to tweak our condition. So we have to merge it on ID as well as on start date. And earlier, right, we were not doing any condition using matched. So now when matched, so if the ID and date is matching, then go and update the target end date or the target description if the description has changed or the end date has changed. Else, you have to do a when not matched insert. So when not matched insert will now work for the new rows, and when not matched by source delete, this will work for ID number 4, which get completely deleted, and partially for ID number 3 as well. Right. So let us rerun this, and let us also run the underscore metadata again. Okay. Now when we sort by row IDs, so your output will still be the same. But if you see here, right, for ID 1 and 2, as expected, it's not a complete entire row level change. Instead, there is some attributes that got changed, right? So for ID 3, whereas it's a complete row level change because even your start period is changing. So for ID 3, it has reinserted, and ID 5, it has inserted new records. For ID 0 and 1, it is only doing a kind of in place update. So yeah, so let us summarize. So to start with, we understood what is road tracking. So road tracking is a new feature which is enabled in Databricks recently, and it's also available in open source Delta. Once you enable road tracking and when you insert some rows, you get an additional metadata field known as underscore row ID. This will track, or this will create a virtual column for each of the row inserted. Now let's we saw that if you use overwrite option, your output in terms of data values, it will be say like it will be properly updated, but it will effectively result in a complete rewrite of the entire data, and that is also highlighted by the row id. Now this option override is useful when only if you have say less than 100 rows, and most of the rows will change. But assume like a scenario where you are doing some historical backfill, and you have say 1 million rows, and out of it only 1,000 rows might change. So in that case, you cannot use a override. So you are going for a merge option. So we first saw effectively what our problem statement is. If all of the attribute is same, then there is no change. So you should not rewrite or disturb that row. So we first come up with a merge query which will check for all the columns, and if there is something not matched, it will do an insert, and if it is completely not matching with the existing source, then it needs to be deleted. So this way we are still will be able to achieve the expected output, but except for the no change data for all the other data, even though we have only certain partial updates instead of a complete change in the time series, everything got changed for ID2. Now, with the option 3, where we understood that we did not do the merge query properly, and we updated our merge query and we match using ID and start date. And based on that, when it is matched, we are doing an in place update. And I mean, technically, even though it's an in place update, it will require some rewrite, but at least the tracking is preserved. So this way, we can see the life like over the period of time, right? For an ID, we can get all the versions, and we can also track the ID. So this row ID will help in understanding the merge. Other additional use cases includes like tracking auditability, how it got changed. We can see those things, but one limitation here is row ID tracking will also have additional space consumed, but it will be minimal. You just need to have two rows, like a row ID needs to be created for each row. So obviously there will be some additional space, but it will be really helpful for all your analysis and to make our queries efficient. That's all I have for the day. Please do like, share, and subscribe.